Chapter 8, Problem 53, Parts A and B only. Watch my other video if you're interested in Parts C and D. And here we're asked, how could you use Diels-Alder reactions to prepare the following products? Show the starting diene and dienophile in each case. Remember that with the Diels-Alder reaction, you're reacting a diene and a dienophile to, in all cases, make a six-membered ring with a double bond in it. All right? So here's a six-membered ring with a double bond. Try to find and locate where that is. All right? And what I like to do is push the electrons backwards as though it's a mechanism, and I work counterclockwise. So always start the foot of your arrow at an alkene. Okay? And then go ahead and take every other alternate bond and just move it around the ring here. Okay? And what you get from this reaction, well, we're figuring out what the starting materials are. The double bond goes away, right? Because we moved it. It's going to create a double bond here. Okay? And if we look at this arrow up on top, we can see how we're going to make a double bond here. Okay? So here's our diene. If we look at this foot of the arrow, it's breaking this bond, and the foot of this arrow is moving away from this bond, so it breaks. And what we're left with is a double bond right here on the right. So this is our dienophile. All right, let's look at this case here. It's a little bit harder to figure out. So you might want to just number the carbons. It's arbitrary. You don't need to try to figure out how it's named or something. Not for this problem. So we'll go ahead and just number the carbons around the ring. And so here's 1, 2, 3, 4, 5, 6. So we want to take this double bond between carbons 1 and 2 and move it to carbon 2 and 3. The carbon 3 and 4, break that bond and move the electrons between carbons 4 and 5. And then take these electrons between 5 and 6 and move them between 1 and 6. Right? So it's kind of hard to show with that bridge carbon coming up, but it's going to look like that. So if we draw what's left over, don't try to rearrange too much, just leave it contorted. So it seems easiest to figure out what's going on this side. 3 and 4 break, and 5 and 6 break. Okay? And what we're doing is forming a double bond here. So we'll have the double bond. Here's carbon 4. Here's carbon 5. Attached to carbon 5, we have a hydrogen and a nitrile group. So there's one of the two products. And then it might be more difficult to see what's going on here. Carbons 1 and 2, the pi bond goes away. Okay. Carbons 2 and 3, we get a double bond. All right. The bridge carbon is still here. I'm going to draw it going up like this. Okay, so here's carbon 6, 3, 2, and 1. All right, the carbon 5, 6 bond breaks. So what we form is a carbon 1, 6 pi bond. So here's carbon 1 and 6. We want to form a pi bond between these two carbons. Okay, we kind of split our bond to show how it's behind this carbon. And now you can redraw this molecule. That's the same thing as cyclopentadiene. Okay, it's kind of hard to see, but when you number the carbons and you carefully follow it through, we didn't number this carbon up here, but I'll just put an asterisk to avoid confusion here, any more confusion. So cyclopentadiene and this molecule here, through a Diels-Alder reaction, would produce this bridge bicyclic system. Watch my other videos for Part C and D if you like. Thanks for watching.